Hello everyone. So today we'll be finding out the critical points of the function x minus 1 whole square plus y minus 3 whole square plus 5, and we'll be classifying the critical points of the function as local maximum or local minimum. So let's get started. Here we have the question. First we have to find the critical points. In order to do that, we have to first equate fx equal to 0 and then fy equal to 0. Let's do that. Fx is differentiating this function with respect to x, which gives us 2 into x minus 1. The other two are constant, so they are 0 anyway. So now fy is equal to 0 means differentiating the function with respect to y, which gives us 2 into y minus 3. Other two are constant, so they are 0, equal to 0. Here we get x value as 1 from this side and y value as 3 from this side. So now the critical point is 1 comma 3. So now our job is to classify this critical point as local maximum or minimum. So now to do that, we have to find the value of d, which is given by fxx, determinant of fxx, fxy, fyx and fyy. So basically if this d is greater than 0 and fxx at the critical point ab is greater than 0, then it is a local minimum. And if d is greater than 0 and this one is less than 0, it is local maximum. And if d is less than 0, it is neither. It is called a saddle point. So now let us find out the value of d. In order to get the value of d, we have to first have the values of fxx, which we have fx. So fxx is nothing but dou by dou x of fx, which is, from here we have fx2 of x minus 1. So differentiating that gives us 2. fyy is given by dou y of fy. Here we have fy, so differentiating this with respect to y gives us 2. So now fxy, which is dou f by dou x, differentiating this with respect to y. So dou f by dou x is given by this. So here, as you can see, there is no y. So if we differentiate, this whole thing is a constant. So if we are differentiating that, we get 0. And the same goes with fyx, which is nothing but dou f by dou y of dou by dou x, which is also 0 since we don't have x in this. So now substituting the values in this d, we get 2 0 0 2. So basically expanding this determinant, we get 2 into 2 minus 0, which is 4. So first case, we are getting d is greater than 0. So we are having two options now. Let us write that down. D is greater than 0. And now fxx at the critical point ab, which is fxx at the point 1 comma 3, is fxx. We got the value as 2, so it is constant, so no need to substitute these values. So anyway, we get 2, which is also greater than 0. So it also satisfies the condition. Fxx at the critical point, fxx at the critical point 1 comma 3 is also greater than 0. So these two conditions are satisfied now. These two conditions, d is greater than 0 and fxx at the critical point is also greater than 0. So now we can classify this critical point as local minimum since it satisfies these two conditions. So the critical point 1 comma 3 gives us local minimum. So I guess we are done here. We have now done the two parts of the question. We have found out the critical points, and then we have classified them. We have found out that the critical point gives us local minimum. So yeah, that's it.